Hi, Les Druven with part 3 of completing the heat loss and heat gain worksheet. Here we have page 3. This is an extremely important page in that this is where we create and calculate all of our heat loss, heat transfer multipliers, and heat gain heat transfer multipliers. Now, I will provide some supplementary videos on how to calculate the effective R values for glass and for the doors. The effective R values for our net walls we completed this in class using this particular worksheet. Our first exposed wall was frame plus brick, and as you can see, we looked at the overall assembly and broke it down into its individual components, found the insulation value for each component, and developed a total effective R value. So frame plus brick, using an R22 bat, we came up with an effective R value of 17.73. The second assembly was frame with drywall both sides. This is a wall between the house and the garage, and so we established that we went through all of the individual components. Initially, we looked at the wall assembly without an additional layer of 1-inch expanded foam. However, we found that the total effective R value worked out to be less than the minimum affected R value as allowed by the Ontario Building Code Standard SB 12. In order for this particular assembly to meet or exceed the minimum insulation value, we had to add an additional layer of insulation. In this case, we chose 1 inch of expanded foam type 1 insulation, which gives us an R value of approximately 3.75, so that the total effective R value comes out to 19.97. That was more than the 17.03, which I believe is the minimum required effective R value for above grade walls when looking at package A1 from SB 12. We had a third assembly, frame plus block. Once again, we broke everything down and came up with an effective R value of 18.4. Then we had a look at the exposed ceiling. With respect to our in-class example, since we're using package A1 of SB 12, we're starting with a nominal insulation value of R60. So when we find our total effective R value, we end up with actually 61.0. Now we can take these 4 effective R values that are on this worksheet, and you can substitute them directly onto this particular page of the heat loss worksheet. So here we have our frame plus brick with the total effective R value of 17.74, our frame plus drywall 19.97, and our frame plus block 18.4. We also did the same breakdown for our basement and first floor headers, but because the construction is the same for both the basement and first floor header, our total effective R value would be equal. And in this case, they worked out to be 24.23. And for our exposed ceiling, here is our effective R value of 61. Now in column 2, we have the actual heat loss, heat transfer multipliers. I did mention that there is a subsequent video that you will see how the effective R values are determined for glass and windows. For glass and doors. However, we can still discuss the heat transfer multiplier for the windows in our example as well as the doors. If you look at the top of column 2, you will see the formula is given to you. It is the heat loss delta T divided by the effective R value. So in our example, because we're building in Markham, we have an outdoor design temperature of -6 degrees Fahrenheit. The recognized indoor design temperature is 72 degrees Fahrenheit. So the temperature difference would be 72 minus -6. However, when you minus a minus, you in fact add. So it becomes 72 plus 6, so we get a temperature difference of 78 degrees. On the heat gain side, we have an outdoor design temperature of 88 degrees Fahrenheit. We have a recognized indoor design temperature of 75 degrees Fahrenheit. 88 minus 75 leaves us with 13 degrees as our summer delta T. So when looking at our heat loss, heat transfer column, you simply take the heat loss delta T, which in this case is 78, and 78 will be consistent. It'll be 78 divided by the effective R value of each of the individual components. So 78 divided by 2.9 gives us a heat transfer multiplier for heat loss of 26.89. And this would be consistent for the windows in all 5 directions. Similarly, we've got our doors. Again, 78 degrees is our heat loss delta T, divided by 6.25, which is our determined effective R value for the door. That gives us a heat transfer multiplier of 12.48. Continuing, we've again got 78 degrees delta T, but in this case now for the frame plus brick, we divide 78 by 17.74 and we get a heat transfer multiplier of 4.39. For our frame plus drywall, we would have 78 divided by 19.97. That gives us a heat transfer multiplier of 3.9. And for the frame plus block, 78 divided by 18.4 gives us 4.24. For our headers, again it's 78 degrees divided by 24.23, and in both cases, because the effective R value is the same, the heat transfer multiplier would be the same, and that comes out at 3.2. Finally, on the heat loss, heat transfer side, we've got our exposed ceiling. We've got 78 degrees divided by 61. That gives us a heat transfer multiplier of 1.27. Now turning to column 3. Column 3 deals with a solar correction, and this takes into account walls and doors that are completely shaded. So you'll notice that in this case we've got, it's grayed out here so that we do have the windows are not included in this particular column, and we will look at how we've calculated these values in a moment. Firstly, any door which is exposed directly to the outside, so typically your front main entrance, possibly a side entrance to a laundry room or side door, because these doors can have sun directly shining on them, there would be no solar correction. In our example, we have an optional door which may or may not be installed between the house and the garage. But because the garage has a roof, the roof prevents any sun from actually shining on this door. And so because of that, we can solar correct the summertime temperature with a value of -6. Moving on to our exposed walls, the main exterior exposed wall, frame plus brick, can be affected by the sun, and therefore there is no solar correction attributed to this main exposed wall. The frame plus drywall is a wall that separates the house from the garage. And so once again, because the garage has a roof, the roof physically prevents any sun from shining against this particular assembly, and so we can solar correct it. And the same thing for the frame plus block, because again, the frame plus block is actually a wall assembly separating the house and the garage, and there is no direct solar radiation affecting this particular wall. Our headers are actually in the exposed wall, and so therefore sun can shine on these particular assemblies, and so there would not be any solar correction. Now when we look at our exposed ceiling, we note that in our example we have an exposed ceiling with an attic above. Now because of the roof and the attic space in the summertime actually can get very hot. And in many cases it will be much warmer in the attic than it is outside. In this case, we will solar correct on the positive side by adding 27 degrees to our temperature difference between the inside of the house and the temperature inside the attic space. That takes us then to column 4, which is our heat gain heat transfer multiplier. And although the equation is similar, it's still the heat gain delta T. But in this case, we have to add our solar correction and then divide by the effective R value. So because windows are calculated separately, they would not be included in this particular calculation, and we will look at this in a separate video. So the first door, a main door, would be the heat gain delta T, which is 13 degrees, plus a solar correction of 0. So that means 13 plus 0 is of course 13, divided by 6.25, which is the effective R value, and that gives us a cooling heat transfer multiplier of 2.08. Now if we look at our optional door, which is a door between the house and the garage, we see that we've got our delta T of 13 plus a solar correction factor of -6. So that would be 13 plus -6. So in fact, that brings us to 7 degrees. 7 divided by 6.25 gives us a cooling heat transfer multiplier of 1.12. If you carry this process through for the other assemblies, you will come up with these individual heat transfer multipliers for cooling. For the frame plus brick, we've got 13 degrees plus 0 correction factor. So that would be 13 plus 0 divided by 17.74 gives us a cooling heat transfer multiplier of 0.73. For our frame plus drywall, we've got a solar correction factor of -6. 13 plus -6 leaves us with 7, and therefore 7 divided by 19.97 gives us a cooling transfer multiplier of 0.35. Similarly, we've got 13, again, plus the -6, so that leaves us with 7, divided by 18.4, and that gives us a heat transfer multiplier for cooling of 0.38. Our headers, both the basement and the first floor, are not solar corrected, so 13 divided by 24.23 gives us a cooling heat transfer multiplier 0.54 for both assemblies. Finally, our exposed ceiling, we've got a delta T of 13 plus a solar correction of 27. So that gives us actually a heat gain delta T of 40. 40 divided by 61 effective R value gives us a cooling heat transfer multiplier of 0.66.